Hello everyone, so today we're going to be going over a problem from the 2021 Berkeley Math Tournament, and this is problem number 6 on the algebra section, so it's actually pretty far into the test, so this is not an easy problem, but we'll show you how to get the solution today. So the problem gives us this, what's called a functional equation, which has a function f and different values of f, and asks us what is f of 1/2. So there's a couple ways of approaching these problems. If you want to try it yourself, my hint would be to try certain values, like try x equals 1/2 maybe, or try x equals, let's say, 3. Try numbers to get a feel of what's happening in the problem. And that's actually exactly what we're going to do. So my approach to this problem is to just try plugging in x equals 1/2 and let's see what happens. So when we plug in 1/2, we get f of 1/2, and also this f of x here on the left side is kind of a hint to try to plug in possibly what we're trying to get and see if we can get something that works. So we get f of 1/2 plus, we get 1 over 1/2 minus 1, that's negative 1/2. So negative 1 over negative 1/2 is f of 2. And then we're going to get equals, and we get 9 over 4 times 1/4, which is 1/2 squared, which is just 9. And then plus f of, 1 minus 1/2, 1 over 1/2. 1 over 1/2 is 2, so 1 minus 2 is negative 1. So let's keep in mind this was x equals 1/2. So part of the trick of this problem is you can actually find what f of x is equal to. But what you can also do is, in similar fashion, notice this kind of circular pattern that these functions have. So let's see what happens when we try to plug in one of these values into our equation, because we're trying to solve for f of 1/2, but we don't know what f of 2 and f of negative 1 are. So let's try to plug in f of 2. So if we plug in x equals 2, what do we get? Well, we get f of 2 plus f of 1 over 2 minus 1, which is 1, so f of negative 1, equals 2 squared is 4, so that's 9 over 16, plus 1 minus 1/2 is going to just be 1/2. And you'll see pretty quickly that there's kind of a pattern going on here. All the functions have the exact same numbers, just in different places. So finally, that kind of gives us the idea to let's just try x equals negative 1. And once we try x equals negative 1, we see f of negative 1 plus f of 1 over negative 2 equals f of 1/2 equals negative 1 squared is 1, so you get 9 over 4, plus f of 2, because it's 1 minus negative 1. So, and let's just make this clear, we see that we kind of have 3 equations involving quote-unquote 3 variables. And I'm actually going to name these. So I'm going to say f of 1/2, let's just call that A, let's call f of 2 B, and let's call f of negative 1 C. And basically we've turned this problem into solving some kind of system of equations. So let's write them out. We get A plus B minus C equals 9. We get, that's, B plus C minus A equals 9 over 16. And finally, we get C plus A minus B equals 9 over 4. And we're trying to solve for A, because that's f of 1/2. So these system of equations are actually pretty easy. Usually if you have 3 variables, you're going to need 3 system of equations to easily find the value of a single number. So But we can actually use only 2 here. So the trick is noticing if we want to solve for a here, we can see if I choose this equation and this equation, we're actually going to just get a at the end, because the c's cancel out when I add them together and the b's cancel out, and we're just going to get 2a. So when I add these equations together, I get 2a equals 9 plus 9 over 4. And from that point, it's pretty straightforward. We just get a equals 9 over 2 plus 9 over 8. And if we end up calculating that out, we're going to get this is 36 plus 9 over 8 equals 45 over 8. So that's the value of f of 1/2. And this approach is great. There's other approaches where you can actually find what f is equal to and just simply plug in f of 1/2. But I think this solution gives a nice insight into the kind of circular pattern of these functions and might give you a clue as to what f actually is if you want to try it, or a trick that you can use. So I hope you enjoyed this solution. Thanks for watching.